So this is the beginning of the midterm review, and don't get freaked out. The midterm is only 20 questions long, right? But because this is a review, it's a list of practice problems. I mean, look at numbers 1, 2, 3. They all look the same, right? You're not going to have 3 or 4 of those types of questions. You're only going to have one of those types of questions on the midterm. But I want to provide plenty of practice for you guys to get good at that one single type of question. So on this video, I probably won't explain every single question. I'll just jump through the different types, and I will provide you the answers for the rest so you guys could practice on your own. So let's do one example together, and then you guys could work on other examples. So like on number 1, which is the same as 2 and 3 and 4 technically, do we remember how to solve an absolute value equation? Yeah. The first step is to isolate it, to get the absolute value by itself, right? It's kind of like if you pretended that this was a big giant x, like if it said 7x minus 3 equals 4, you want this by itself. So what would you do first? Would you get rid of the multiplication of 7 or the subtraction of 3? The subtraction, right? So how do you get rid of it? By doing the opposite, which would be plus 3. And what you do to one side, you must do to the other, plus 3. Again, step 1 is to isolate. Now you're going to have to write really small here, so bear with me. You know, maybe for the sake of having enough space, you might want to rewrite your new equation over here to the side, and it would say 7 absolute value 2x minus 9 close absolute value equals 7. So what would your final step be? Divide by 7, and now we finally have our isolated absolute value, which is the absolute value of 2x minus 9, close absolute value, equals 1. So that is step 1 on solving any absolute value equation. You first have to isolate the absolute value. Now, step 2 is where the real work comes, where you do the positive situation and the negative situation for that absolute value. And again, in my class, I recommend you actually write out the word pos, neg, squiggly line in between, right? Now, I hope you remember from way at the beginning of the school year that the positive situation would be writing it exactly the way it is. So right here, instead of absolute value of 2x minus 9 equals 1, you're just going to write 2x minus 9 equals 1 without the absolute values. So let's write 2x minus 9 equals 1. For the negative situation, we end up with just the exact same thing, but let's flip the 1. I mean, not flip the 1, but change the sign of the 1. So it's going to be exactly the same, 2x minus 9, but change that 1 to a negative 1. I'll even put the negative in red so you could see that actual change. So that's your two situations. You need to solve both and get both answers. So on the left side, we're going to go plus 9, cancels, plus 9. We'll have a new equation that reads 2x equals 10. Finally, we're going to divide by 2, x equals 5. That's one answer. Okay? The other answer will be plus 9, You'll have 2x equaling 8. Final step will be to divide by 2, x equals 4. So those are your two answers for number 1, 5 and 4, 4 and 5, whatever. Keep in mind, ladies and gentlemen, that if you end up with a negative, when you isolate the absolute value, like let's say at this point, let's say this 1 would have been a negative 1. Do you have to do any other work? No, why not? Because you cannot have an absolute value equaling a negative number, right? Okay, so if you end up isolating it, you end up with a negative number over here. That's impossible. You would just stop and say no solution. That might happen on one of these next examples. I would say go ahead and practice, but number 2 is a little different than the rest. As you could see, number 2 has a variable on the right side. Over here, it didn't have a variable on the right side, so it's definitely worth explaining number 2 as well. So let's go and do number 2 right here. What is step 1 of solving any absolute value equation? To isolate it, right? This absolute value is already isolated. There is no times 5 out here or plus 7 back here. It's already isolated. So I could jump right in to doing the positive and the negative situation. So the positive situation is going to be writing this exactly the way it is without the absolute values. Pretty simple. Now the negative situation is going to be writing it exactly the way it is, but we change the sign or signs of whatever's on the right side of the equal sign, okay? That's what we've always done. The only difference is right here we actually have a binomial. There's two terms, so we're going to have to change both of their signs. Some people just change this one and they get the whole thing wrong. You have to change both of their signs. So let's leave everything the way it is. The 3x minus 1 is still there. We're going to have an equal sign. Now here's where it changes to a negative 2x and also a minus 26 instead of a plus 26. So you have to change the signs of the right side of the equal sign. And now let's solve both. So on the left, let's get x's to one side. Subtract 2x. Subtract 2x. We'll have 3x take away 2x, that's 1x. Bring down the minus 1 equals 26. And then add 1 to both sides. We will get x equals 27. That's one answer. And the other one, let's do the same. Let's get rid of the minus 2x by adding 2x. Adding 2x. We will end up with, let me change colors here, 5x minus 1 equaling negative 26. Final step would be to get rid of that minus 1 by going plus 1 and plus 1. Well, final two steps, that is. You end up with 5x equals negative 25. So you'd have to get rid of this multiplication of 5 by dividing by 5. And you will get x equals negative 5. So those are your two answers. There is one thing we must do. We must plug in our answers to verify that they work. I guess I forgot to do that up here. So you must take a second or two, take the 5, plug it in. 2 times 5 is 10, minus 9 is 1, 7 times 1 is 7, 7 minus 3 really is 4. This one works. Plug in 4, 2 times 4 is 8, 8 minus 9 is negative 1, but the absolute value of negative 1 is positive 1, so you end up with the same answer. Both of these up here work. But when you check both of these down here, let's see what happens. 27 for x, 3 times 27, that'd be 81, and then 81 minus 1 is 80, so you have the absolute value of 80, which is 80, and when you plug in 27 over here, 2 times 27 is 54, plus 26 is also 80, so this definitely does work, yay? All right, now if we plug in negative 5 right in here, 3 times negative 5, that's negative 15. Negative 15 minus 1 is negative 16. So the absolute value of negative 16 is 16. So we have 2 times negative 5, that's negative 10, plus 26, that is 16 also. Both of these work. But it's still important to check because you might end up with extraneous solutions. All right, so I want to leave it off right there and jump to the next type of question, which is solving each inequality. Okay, solving an inequality is exactly the same as solving an equation. You want to simplify it first, do distributive property or combining like terms. You want to get x by itself on one side. The only difference is that if you ever divide or multiply by a negative on your last step, you have to flip your inequality symbol. So maybe instead of 5, let's pick one that's a little more challenging, like number 7 looks good, huh? Let's do that one, because if you could do 7, you could do any of those. So let's jump to number 7 better. So let's distribute. And when you distribute, I recommend circling the number that you're going to distribute and include the sign that's in front of it. So negative 4 times x is negative 4x. Negative 4 times negative 2 is a positive 8. Bring down the 5x that's out there in the front. That's distributive property. Now we have to combine like terms. So let's combine the 5x with the minus 4x, giving us 1x. So we have one single x plus 8, and that's all we could do on the left side. Now let's simplify the right side of this inequality. 3 times x, that's also 3x. 3 times 1, that's 3. Bring down the minus 7. After distributive property, it's combining like terms. Combine the 3 with the minus 7. You do that in your head, you'll get a minus 4. So what we really have is the 3x minus 4. Let's not forget about this inequality symbol. We need to bring it down in between the two. It's a greater than symbol. So now let's solve getting x by itself on one side. So obviously I have x's on both sides. That's not good. So you have an option of moving this x over here or moving the 3x over here. I recommend when you're dealing with inequalities, move the x's to the left, because the answers are going to be given to you with the x on the left side, with the variable on the left side. So I recommend subtracting 3x. Subtracting 3x, you will get negative 2x plus 8 is less than negative 4. My final two steps would be to subtract 8, subtract 8. You're going to end up with negative 2x is greater than negative 12. Final step will be to divide by negative 2, divide by negative 2. And this is where I hope you don't mess up. X is less than 6. You do have to flip this inequality symbol. You have to flip it because you divided by a negative on your last step. So that was the hardest inequality that we had to solve. That one's easier. This one down here is way easier. So we're good with those, at least for now. We have now compound inequalities. Now, what's a compound inequality? When you have two inequalities put together in one. And we have some that are actually written together as a compound inequality with x in the middle. And you want to solve that by getting x by itself in the middle. All right, so let's do this compound inequality on number 8. And if you could do number 8, if you understand number 8, you'll be able to do number 9 easily. So I need to get rid of the minus 20 by going plus 20. And what you do to the middle, you do to both outside sides. So go plus 20 over here and plus 20 over here. So our new compound inequality is a negative 4x right in the middle, the same inequalities. But over here on the left, negative 8 plus 20, that's 12. And on the right, I have 48 plus 20, that is 68. Final step, well, almost final step, is to divide by negative 4, divide by negative 4, divide by negative 4. So the 4's cancel. You end up with x in the middle. Now we did divide by a negative. So what does that mean with the inequality symbol? You have to flip them. So it's going to end up flipping this way. And 68 divided by 4 is 17. Thank you. Negative 17, that is, right? Okay, so I do not believe they're going to leave the answer like this. Why not? Because whenever, I mean, they might, but I think, and if it were my open response test, I would rather you write it the way we always do, with the smaller number on the left side, the bigger number on the right side, right? So this whole thing needs to get flipped around, all right? I need to flip this whole thing. So the smaller number should go to the left. The negative 17 should be over here. The negative 3, the bigger number, should be on the right. The x should be in the middle, which means that we need to flip these inequalities back to this. I believe this is how they're going to give you the answer on the multiple choice. I mean, technically this is not wrong, but this is way better looking, right? It's in order. Smaller number on the left, bigger number on the right. All right, so you guys should be able to do number 9 with that example. We also have these compound inequalities with the word or between them. All you got to do is solve each of them, right? Okay, just solve each of them. What else? Do we need to see number 10 or do we got this? It's like 2 problems in one. It's really simple. All right, let's skip number 10. Let's jump to number 11. Man, I'm feeling bad for skipping 10. Just solve that one, get an answer. Solve that one, get an answer. And write both of your answers, but put the word or right between them. That's it, right? You don't have to write it with the x in the middle, smaller on the left, bigger on the right. No, if the word or is right there, just put both answers with the word or between them. Okay, so we've already done absolute value equations. Now let's do absolute value inequalities, which is almost identical. Step 1 is the same. What's step 1? Isolate the absolute value. So what do I need to do? Add 18 to both sides. Get rid of that minus 18. So my new absolute value inequality is absolute value of 3x plus 3 is less than or equal to 12. Now that it's isolated, I could do my positive and negative situation. The positive situation is writing it exactly the way it is without the absolute values. The negative situation is writing it exactly the way it is, but you want to flip the inequality and change the sign or signs of the right side of the inequality. So write it exactly the way it is, 3x plus 3. But once you get to the inequality, you have to flip it, and then you have to change the sign or signs on the right side of that inequality. So again, on the negative situation, you had to do this. You had to switch it, and you had to add a negative. Okay. So now we just got to solve both. Minus 3, we end up with 3x is less than or equal to 9. Final step would be to divide by 3. Answer is x is less than or equal to 3. Okay, I'm not going to circle it, I'm not going to box it in yet, and I'll tell you why. Let's just do the negative situation first, though. So we're going to subtract 3 over here, We're going to have 3x is greater than or equal to negative 15. Final step will be to divide by 3. X is greater than or equal to negative 5. Now, these are my answers, but because they're inequalities, I need to determine if I need to write these together as a compound inequality with the x in the middle and the smaller number, negative 5 on the left, and the bigger number, positive 3 on the right, or maybe just put them both right next to each other with the word or right between them. Okay, that's very important. And the only way to figure that out is to think about their number line. Okay, so on a number line, let me do a quick sketch of a number line up here. On a number line, here's, let's say negative 5 is right here. Let's say positive 3 is right there on a number line. And let's look at this answer right here. X is less than 3. Less than is to the left or to the right? To the left. So as you can see, it's going this way. I mean, if you wanted to be very thorough, it'd be a solid dot going that way. And we look at this answer at negative 5. X is greater than or equal to negative 5. If you want to be thorough, solid dot going to the right. So this area is together, which means I have to write my answer together as a compound inequality with x in the middle. You cannot leave it like this, right? If you leave it like this with the word or between it, that'd be technically incorrect. So we'd have to write this as a compound inequality with x in the middle. It's really easy to do. Just put x in the middle, put the smaller number on the left side, which would be the negative number, the bigger number on the right side, which is a positive number, and then you simply put these inequalities, the less than or equal to inequalities. Of course, because we had the or equal to there. But this is your answer. This is your final answer right there. Right here. Boom. Compound inequality. Now, if the areas up here, if I would have gotten a visual and I see that they point apart, that's when we just keep these answers and put the word or right between them, and we would be done. So I believe you guys could do number 12. And that wraps it up for this front side of the page. Let's work on the rest. Go for it. Okay, so it was brought to my attention that the answer number 5 and 6 are funky. And they're funky on purpose because you're probably going to end up with some funky answers on the midterm itself. So let's take a look at number 5. Let's distribute negative 6 times 2x, it's negative 12x. Negative 6 times negative 1, that's positive 6. Bring down the inequality and the 27. Let's subtract 6. We're going to end up with negative 12x is less than, what is that? 21. Thank you. And then final step would be to divide by negative 12. Divide by negative 12. So your answer will be the 12s cancel. X is greater than, you have to flip it because we divided by a negative. Now we cannot really divide 21 by 12. If it were 24 by 12, that'd be nice. But it's 21 over 12. So at the very least, we could possibly reduce. We have to attempt to reduce. So we could reduce by 3, both top and bottom, and we will get, let's write our negative sign right in the middle or on top, but never leave it on the bottom. 21 divided by 3, that's 7. 12 divided by 3, that's 4. So there's your final reduced simplified answer for number 5. X is greater than negative 7/4. So I believe the next one also works out like that, like a fraction. Don't be scared, right?
Can we leave it as a fraction, or can we put it as a decimal?
I would leave it as a fraction. And if for some reason they ask you to find your answer and the correct graph on a number line, if they show you a number line, then that's a different story. Because you need to change this improper fraction to a mixed fraction, right? So 7 divided by 4. How many times will 4 go into 7 without going over? It'll go in 1 time. You'll have a remainder of 3 over the original 4. So this would be more appropriate if they gave you a number line. So you'd be at 0, 1, 2, let's say -1, -2. So you'd go to -1 and 3/4 of the way. 1/4 is right there, 2/4 is a half, 3/4 would be right here, 4/4 would be to the next whole value. So right here is 3/4. So right here you would put an open dot if they asked you to, and it would be going to the right, because this is a greater than symbol. I don't remember exactly if they do give you a number line graphed or not. So I don't know if they just want this answer, or maybe they show this answer and you'd need to think about this, or maybe changing it to a decimal on your calculator to be able to understand which one's the correct number line. Okay, I've spent too much time on the first page. I apologize. Let's work.